All right, so second semester, and it starts off with probably one of my least favorite topics, conics. So, Unit 6, we're going to be talking about conics. Basically, conic is anything that can be done from the shape of a cone. And you might think that's very limited, but a lot of the curved things that you've done in the past in geometry and things like that have all come from conics. So circles, any curves, parabolas, all of that essentially comes from conics. You can watch this video to kind of see how they talk about how conics plays in the San Francisco Gate Bridge and how it's used in architecture. So let's kind of take a look at a cone. So a cone, you see, it's a circle, it has a circular base, and it kind of has this triangular point. Um, but if we look at a double cone, we can kind of start seeing a lot more to it. Uh, there's this slant right here, slant height on a cone. Here it kind of goes through to another cone. And then you have the axes where everything is kind of symmetrical based off of there. So let's talk about cones. So cones, we can get a circle. Obviously, I mentioned that the base is a circle. If we cut it at a straight line, there's the circle. Cut it at a bit of an angle, that's an ellipse. Um, Next, if we cut it at a slighter angle that hits the bottom base, you get what's known as a parabola. If you slice it straight up and down, you can't see it on this one. I'm not the biggest fan of this picture. They should have done it with the double cone. Here, I'll show you. So if you look at a double cone and you cut it straight up and down, I'm not sure what they were thinking when they did this, but if you cut a straight line up and down, you kind of get this double parabola type thing that's known as a hyperbola. Not hyperbole, it's not really an exaggeration. Hyperbola has two different curves, and if you do it at different angles, you can have different shapes happening with both parts of those parabolas. So hyperbolas kind of look like this. We'll talk about them later in later modules, but for right now, we're going to be focusing on parabolas. So and this is all based off of if you've taken geometry, you've probably seen what's known as a cross section. So conics are essentially cross sections of a double cone. And here you can see that that's what I was talking about, cutting it straight down to get that double conic or double hyperbola. So and we see conics everywhere, circles, um, hourglasses, water when it's going up and then back down. They're essentially everywhere. So conics have a few interesting properties. Um, some conics are very simple. So if I took a cross section of the center, that's just a point. If I took a cross section right here, that's just a line. Going like here, you can't really see it so well, but what's happening is they're talking about this line and this line. They just kind of have it this way. So it's two lines that are crossing each other. So there are several types of different types of shapes that can come onto it. But when we really talk about conics, we're talking about these shapes in particular, and they all have different formulas. So for example, if you have ax plus by equals c, this is a line. A and b are not equal, and don't are not are both not equal to zero. Otherwise, it wouldn't really be that good of a line. And then we have other types of formulas. You might see this familiar as a how can I describe it? It's a quadratic, but with two variables. And those quadratics with two variables, the way they interact with each other makes things differently. So, for example, if I zeroed out this c, I would get a parabola because then I would just have a squared. I would have a y there, but that's typical. We can always factor stuff like that out. So we're going to talk about the different shapes, and we're going to try to match each of these. So if I look at this, cutting it down, this is what's known as a hyperbola. That double parabola figure is the hyperbola. Cutting it straight, as long as this is perpendicular, parallel to the base, this is going to be a perfect circle. Any slanted it whatsoever, such as this one, you automatically make it an ellipse. And of course, a parabola, as I mentioned, is when you take that cross section and cross it kind of at an angle. So it doesn't cross down here. So it can't be perpendicular. If you do perpendicular, it's automatically going to be hyperbola. So if you have it somewhat of an angle, you're going to get that parabola. All right. That's it. I really wish all of this is going to go fast, but let's talk about parabolas. So we've seen parabolas in one way. Um, it's parabolas only being affected by the y. We've had a few formulas like this. We had y equals a x minus h quantity squared plus k. This is how it's going to, this is known as vertex form. You've also seen standard form, ax squared plus bx plus c. One thing I learned from teaching that I found really interesting and I didn't know when I was in high school is these a's are actually the same value. I had no idea that the leading coefficient would be the same. It makes sense after like learning it for a while, but it was just interesting to me because normally variables are just variables. And the last form is actually something we're going to learn about now, where they're, how can I put this? They're dependent on something else. So I'm going to talk about this right now. And they describe it, they probably describe it a little bit better than I do. I'm actually not so familiar with this lactus rectum. I think it just means that it is going to be parallel to the directrix and crosses through the focus. So we're going to talk about this. The directrix is sort of like this line that's kind of made up, but basically what a directrix is in a parabola, there's this thing called a focus. So this focus, it's actually kind of interesting. So a focus in real life, like let's say this was a curve of a flashlight, if you put a light right at the focus and it's bouncing off of a reflective parabola, it would bounce here and automatically bounce going straight forward. So that's why you want to get that. That's why a focus is so important because of how it's directed. Now you might see these lines like, wait, these are going downwards. So the interesting thing about a focus is a focus, well, let me go back to explain what a directrix is. A directrix is a line that exists that has the same distance from the focus, so the distance of the focus to the directrix. There's always going to be another line that has an equal distance from here to there. Um, so let me kind of explain this a little more. So let's say I have this point A. The distance from this to this arbitrary line right here, I guess it's not arbitrary because we're going to explain why it's so special right now, is always going to be the distance from the focus to here. So there exists a line for every point. This isn't just one point. Every point on the parabola. So this point here, the distance from here to here is the same as from here to the focus. So this focus is kind of like this center that, and it's very interesting because why would there be a line here that's the same distance? So the next formula that we learn about for parabolas is actually in relation to this line here. More specifically, it talks about the distance from the vertex. Oh, and obviously, if the vertex from here to here is going to be the exact same distance as, so from the vertex to the directrix is the same distance as from the vertex to the focus, by definition of what a directrix is. A directrix means they have the same thing. So this is probably very useful. We're gonna later on we're gonna call this P. So we're gonna learn about how parabola can be formed with this focus right here. Usually we're talking about how the independent variables and the dependent variables are x and y, how y depends on x. But interesting enough, we're going to see how y depends on this x as well as this p. So let's get into that right now. This one, I'm probably going to do 2 videos. They'll both be released on Friday. I just might need some time um, to rest in between videos because it is a pretty long topic. So this idea of a focus is what I was talking about here. If you took a string right at the focus and you go here, you can detach the string from the focus to a point on the parabola and drop it down, and it'll hit the straight line on the directrix. So they're kind of symbolizing it by this idea of let's pick a distance from this point, and our lines, and we're going to have a straight line that's always here, always at that distance. So when you draw this line, you can keep giving it more yarn. But interestingly enough, that yarn has to be the same distance over here. So we'll kind of see this a little bit more. Like I said, that's a weird explanation. I wasn't the best at kind of like explaining the drawings. But you can read more about it here. They probably do a much better explanation than what I did. So let's kind of talk about this activity. So we're going to graph parabolas using the method discussed on this website. So there's a, so interesting. I don't know why it's like using this. So we're going to use Desmos to kind of graph whatever parabola they talk about. So in this lesson, we use common tools to draw a parabola in each of the graphs. So we're going to actually use practical tools, but we're going to do it in Desmos. So with the blue line. So this is going to be our directrix. Graph the parabolas using the method discussed in the lesson. Okay. So again, we're going to be, I feel like this is supposed to lead me somewhere else. Graph parabolas using the method in the lesson on the website here. All right. I feel like we're missing something. Give me a moment while I go back and read it. All right. So I tried looking everywhere, and you guys might notice some time that lapsed since I paused the video. So I tried looking everywhere, and this just there's no tools provided on Desmos from what I saw. So I'm going to show you guys how to kind of start it doing this, as well as some ways to manipulate it. So let me close this. That way it doesn't confuse anyone on, well, how did you get there? We'll get through that right now. So I'm going to click the link, and they don't give us many tools. So what we're going to do is Desmos actually has some pre-constructed graphs here. Our job's going to be to manipulate this in a way that'll help us. So what we're going to do here is we are going to, let's get here, going to so from here, we're going to scroll down, go all the way to Conic sections and parabola. It's a little cut off. I don't think there's a way to kind of expand it, but you can tell this is supposed to be parabola. Click open graph. So now we have this. Now this is a function dependent on the location of um, the P. So we're supposed to learn this later, but I honestly just can't find a way to do that without um, without changing this. So we're gonna, spoiler alert, this is the formula that we're gonna be learning. So what we're gonna do here is try to match this to the graph that they're talking about here. So here they want our focus to be -1. So somehow we got to get this focus to be -1. So let's see. And by the way, I haven't messed with this yet. This is just a way I think we're going to start working with this. So what we're going to do here is, if that's the x-axis, I actually think this might not work now that I'm looking at it. But here's hoping. So the directrix is 1, 2, 3, 4, 5. So the directrix is at -5. So if we look down, we see that directrix. We want our focus to be down here. So let's see if I can somehow get that. So I want that to be -1. Okay, so I'm just going to make my focus -1. Let's see. So I did that, but now I want this dependent on this point right here. So as you saw, I changed this to be 4, this to be -1. So I want somehow for this to be related to these two. And that's going to end up having to be the number in between these two. So I'm going to want my P uh, to be, first of all, I want this to be lower. I want this vertex to be down here. So I want that to be in the middle of these two. So if I add these two together, I get -6, cut it in half, that's -3. So let's lower this graph down 3. Perfect. So this should end up being my parabola. Um, the only thing I don't like about how we ended up solving it, though, is the fact that if I change this P, it's not really changing much else. Let me show you what I mean by that. I'm going to undo everything to show you how it was originally. So this was the original one. If I change the P, the focus changed, and I can zoom out just so you guys can see that. So the focus is changing here. So what I'm going to propose is we're going to want to move this all down a specific amount. So if we look here, what's in the middle of this? We said that was -3, in between -1 and -5, that's -3. So let's just move everything down 3. Now, what I want to do here is I need this to also move down 3. So this is supposed to be -P. So I needed to move down 3. So I'm going to move everything down 3 by literally just putting -3. This is going to be -3 as well. So this should, in theory, work. Everything was kind of already set up. The only problem that we had before was that everything was lower by 3. Okay, so as you can see here, we have that relationship going. So the way I determined how far down I was going to move was the center. So I want my P to be 1. So if I put my P as 1, do I want my P to to be 2? I actually do want P to be 2. So I went too far down. I wonder how I went too far down. -3, -3. but we're going to add one to it. Huh. Was I supposed to go to 4? So let's see if changing this to 4 helps. Nope, too far. We want it bigger than that. So, I guess that didn't help it. I'm just trying to figure out where we want this line to be. That's at -4. I feel like it should be 2. We're doubling the distance. Okay, so it is at the center. The only thing that I can see wrong here, the vertex of it. Well, it worked. May not have worked with a P being 1, but I guess our P has to be 2 in order for this to work nicely. So we can do that. And what we're going to do now is we're just going to take a screenshot of this. There's a few ways you can do that on a Chromebook. Let me show you how to do it on a Chromebook. If you're on a Chromebook, screenshot. So if you're on a Chromebook, you have to control, okay, hold on. Control F5, or if you're on a different type of Chromebook, you might have to hit Control Shift and this little button right here. It should be your F5. 1, 2, 3, 4, 5. Yeah, it's F5, but you can see it's a little picture. If not, Google it as you saw to do it. I'm on a Windows 10 computer, so I use this little snipping tool. Or you can print screen and paste it onto something else. Or you can take a picture of your phone. I'm going to snip. So what happens when we snip is we get this little tool when we open up. We're going to click new, start a new snip, and I'm going to snip this. You can also look up how to snip on a Chromebook, but what I'm going to do is just snip that, and I'm going to Control S to save the image. And what I'm going to do now is write snip 1. So I do that. And I'm just going to go here to my insert image. It's this little mountain with a sun. And I'm going to go to choose file. Go here. And voila, we have this. They can even see how we did it. So that's one way of doing it. Not the biggest fan of it, but it does have the focus, the Directrix, and everything. So now, if we look here, this one's going to be upside down. So if we want this upside down, first of all, let's figure out where our center line should be. So I'm going to look and see what's in the middle. It's in the middle of this. So this is -2, and this is 1, 2, 3, 4, and a +4. So if I add these two together, I get 2. So I want a center line somewhere here at the +1. That's going to give me a distance of 3 here and a distance of 3 here. So my P should be 3. Let's hope I did this right this time. I'm not sure what happened the last time. So again, you can start it up, but I'm going to start this up a little differently. So I need this graph to start at 0. We're at 0, 0, but then we have to do a +1. Now, here's the thing. My focus is going to be a little off. So what I want to do to kind of move my focus to the left, so hold on, let's move everything. We're going to do +1 here. We're going to do +1 here. So it looks a little better. It should be centered now, ideally. So this should be in the center. Oh, totally realized what I've been doing wrong. This is the focus. It shouldn't be a plus. I've been adding it to the distance between them. So this should be a lot better. I shouldn't have been adding it. I made everything there. So this is 2. This is -2. Okay, this should work ideally. We'll see. So this from here to here is 1. Still not working. The distance from here to here should be 2. So let's take a look here to see what's going on. What can I do to move this up? So this makes sense so far. Moving this moves the focus. Again, this is troubleshooting. I apologize for not having this planned out. It would be a lot easier for me to do it in a drawing with paper, but I'm trying to do this with tools that you'll have access to at home, and I was assuming that by giving me the link, it would help out. Let me pause recording while I mess with this, and then I'll explain. So I didn't exactly solve the problem, but I think I know what we need to do. We need to move everything, and it looks like we're going to move everything. Oops, let's see here. Wrong pen. We're going to move everything to the 1, 2, 3, 4, 5. We're moving 5 to the left, which means we're going to want to put this as parentheses. So from our transformations that we've learned before, it's always going to be the opposite of what we want. Oops. Literally explaining I wanted the opposite, and then I type in the wrong thing. We want it to be the opposite, so that's why I put that +5 there to move everything over, which means this can no longer be 0. This has to be a 5, -5. This one is exact. It's exactly what it means. Let's fix this. We want things to move a little bit more. You know what? I didn't submit the last one, so I don't know if it actually wants it to be in the center. If it does, then that kind of changes things a lot. So it doesn't. It just wants it in the center of those two. Okay, so we have this. Now, what we want is we need to find this middle ground, which we said was +1. So we want everything moved up 1. So I'm going to do +1. This is going to be +1. This is going to be +1. Now, the only issue is we want these kind of backwards. So we're going to have a -p. Now, the distance of this, so we want this to be +1 here. So if we have this +1 here, we said that the distance here should be 3. So ideally, our P should be 3. So let's see if this can work. So let's try -3. I feel that's a little too much. So it's at -2. And okay, so that's -2. I'm just zoomed in a lot. And that's at a +4. So 1, 2, 3, 4. Yep. So we did this. I'm not sure what I did wrong on the last one, but here we go. So let's get this snip done. So we're going to open the snip. We can see our old snip here. The beauty of this is you can always like use a pen and write stuff in. But we're going to do a new snip or screenshot or what have you. I'm not taking a screenshot because, oh, that's not showing the Directrix. Let me zoom out a little bit more. I'm not taking a screenshot because I have two monitors, so it'll just end up showing both monitors, which I kind of don't want to do. So I've been using the snipping tool. Where'd my mouse go? There we go. So I'm going to use the snipping tool or whatever tool you can to snip or screenshot. So let's take this and I'm going to call it Snip2. So Control S, call this Snip2. And that's how you're going to do that. I mean, you guys can see how to upload it by rewinding the video. So let's go to the next one. Now, here's something interesting. We're changing the directrix. So what we want to do now is this is no longer going to be a horizontal line. It's going to be a vertical line. So we change this to x equals. All right, so we're going to change that to x equals. Ooh, this is no longer going to affect our y. It's going to affect our x. So we're going to change this to, let me put this at 0. And I'm going to change this to p. All right, so we have this going on. This, we're no longer, let me write this back down the way it was. Because we're switching how this is, this can no longer be an x. We're going to change this. This is going to be our new x, so you're going to see weird stuff happen, but this should be our y. So you see here that the parabola is still being affected the exact same way. Let me get rid of this +1 here. Okay, so we can see this right here. You can see how the parabola is being affected. Oh, let me get rid of this +1 here. There we go. All right, so now the question is, where are we going to want this vertex? The vertex has to be in the middle of them. So in order to figure out where the vertex would normally lie, we have to figure out what's in the middle of the focus and the directrix. Again, I'm not sure if this is how they want it, but I'm working with the tools I have. -1, 2, 3, 4, -5. So this is -5. So we want -5, and then this is -2 or +2, sorry, +2. So -5 +2, we're going to end up getting this 3. We want to find the, I'm starting to see why I messed up on the last one. The distance between this isn't -3. The distance, oh my gosh. We need to find the average distance between these two. So the distance between them would be a line at, let me close this up. This is confusing me. All right. So we need to find that line in between these two. So if this is at 2 and this is at -5, -5 +2, we get this -3. So we're going to want our line somewhere in the middle of it, which unfortunately is -1.5. Ugh, that's terrible. So we don't want this at 0. We want it over to 1.5. So normally moving it to the left, we would affect the x. So I'm just going to subtract -1.5. So -1.5. We're also going to want everything else to shift over that much. So I'm also going to put -1.5 here. And I'm going to make this also go -1.5 here. So that you can see moved everything. The distance in between them, so our P should be that -1.5. Um, and, oh, that's from 0. So from negative 1.5 to get all the way to negative 5. So I'm predicting that's going to be negative 4.5. Or, sorry, negative, here, give me a second. The distance between negative 5 and negative 1.5, that means our directrix should end up being, I guess, negative 1.5 plus 5. Uh, because I'm going to see how we get over to here. We're going to get 3.5. So we should have about a 3.5 for this. Give me a second here. And it should be negative because they're in opposite directions. So if I look there, I see, here we are at 0.5, and over here we're at 2, which is exactly what we wanted. So I know I kind of did the math a little weird here. Let me kind of explain it a little bit more. So I'm here at negative 0.5. My goal is to get the focus here at negative 5. Okay, so I need to figure out what the distance from here to here is, from here to that 1.5. Well, that's halfway between here and here, so that's at 3.5. Now, if I did a positive 3.5, I would be adding 3.5 to this, which would end up giving me right here where the directrix is. So I kind of had to go a little backwards and do a negative 3.5. Hopefully that explains it better. Even more hopeful you guys understood it despite my butchered explanation. So here we can have a really good snip of it. So let's get a picture of this. There's a nice little snip. We're going to call this snip 3. So Control S. We're going to call this snip 3. All right. So now we're going to upload this. So we're going to go here. Go to our image. Just a refresher. I know I didn't do this for the last one. So go to Snip 3, open that up. Boom. All the information's there. All right, graph 5. All right, so now we need to find where this is still going to be a horizontal parabola instead of a vertical parabola like we're used to. So we need to find where that vertex is. So that vertex is going to be in between these two. Luckily, this is easy to calculate. So we can see 1, 2, 3. So we want it 3 to the right. So we're going to do plus 3. Plus 3. All right. And so if we're doing plus 3, we have to do plus 3 to all of the p's that we've been doing. All right, feels a little better. Now, if you look here, we want this, the vertex is right, okay, so we want the vertex in between these two, so it's right here. So the distance from the vertex to here is only 1. So luckily, that makes it easy to calculate. So we're just going to change our p to be 1. Cool. So if you can see here, I have this. Now the only problem is I have all of my x's correct. You might have just noticed that my y's are a little off. They're a little higher. That wasn't so much of a problem. Oh, it was a problem there. Huh. I totally forgot to fix the problem here, but I'll show you how to fix it right now. So apologies for that. We'll see that my y's a little off. 1, 2, 3. I need all the y's to be up 3. So I'm going to change this from 0 to 3. Don't really need to change much as far as an x equals, like that's fine. But we do need to make this y go up 3. So I'm going to change this, parentheses, I'm going to do -3, because again, it's always backwards. So here you can see that I fixed it. If we needed to fix it over here on this problem, I honestly didn't realize it because it was only doing this. We would have to put a -1 inside the formula here. If you guys can barely see it, I just know where it is based off of the context of this. So we put -1 here. And instead of putting a 0 here, like we did on the last one, it should be 1. And again, we don't really have to change much for the Directrix. The Directrix we don't really care about the y value because it's all y values. So this will be a pretty good snip. What I'm going to do though is I'm going to move over so we can see the graph a little better. And I am going to grab this, go here, and take my last, I believe this is the last snip. So Control S, call it snip 4, save my snip 4, going over here, and I'm going to insert my image, grab it from wherever it's at, and boom. So self-evaluation. This I'm giving myself a 2. I had no idea what this activity wanted from me. There were no tools to do it on Desmos, but I do think I understand the relationship from key and the graph. So hopefully that helped. I am going to cut the video here. I know I've had a lot of pauses that, well, you can't see. You probably just, if you're paying attention to my clock, you're like, that clock keeps jumping. But I do kind of know that this is going to be a long thing for people to get through. I am going to redo question number 3 right now because I know I messed up on it and I want you guys to have the correct answer for it. But that's pretty much the end of this video. If you guys already figured out how I messed up on 3, awesome. If not, I'm going to go through it right now. And then after this problem, we'll get to the next video. So let's get back to number 3 because I don't want you guys having the wrong answer. So if I look here, I'm at -5. Let me do a darker color. I don't like that. Yeah, -5 here, and I'm at +2 here. Combining them together, I would get -3. So cutting that in half would be -3/2, which I said was -1.5. So at -1.5, I need to find the distance from here to here, or I can just look at it as, hey, if I cut these two in half, I end up getting, I get this -3.5. So let's, I mean, how can I explain this better? The distance between these 2 points, oh, that's a better way of explaining it. The distance between these 2 points is 7. So if we cut 7 in half, we get 3.5. So our P should be 3.5. All right. So first I need to find that line. So my vertex has to be at, give me a second. Let me fix everything here. So it's kind of at the default. My vertex has to be at, oh my gosh. All right, So this should be basically how it is if you're doing the horizontal one with the X here, the Y here, all of that. So I kind of want to move my vertex over. So I'm going to have to essentially subtract 1.5 from everything. So I'm going to do minus 1.5, minus 1.5. Here we're going to do minus 1.5. Cool. Everything's kind of set except for the distance. So we said the distance was 3.5. But if you notice here, they're kind of in the wrong direction if I do 3.5. 3.5. The focus is where the direction should be, and the directrix is where the focus should be, at least according to this picture. Let me erase all this. At least according to this picture, it is. So what you want to do is you want to switch it to be a negative 3.5. That way you get them where they have to go. Cool. Everything's kind of where it has to be now. The only thing is we need to move everything up 1. So if we want to move up 1, because now our x is dependent on our y, now we're going to do the opposite of y. So instead of adding 1, we're going to subtract 1. Boom, it went up. This, instead of 0, is going to be a 1. And now we have the correct picture. So I guess it was a good thing I didn't upload. Well, I did upload this one. I didn't upload 2. Great. I uploaded the wrong one when I could have just not done it. And so now we're going to do this. We're going to go here. For the sake of my records too, since I did mess up on it, I'm still going to call this Snip2. And an easy way to do that is click Snip2. Hit save. It's going to be like, hey, do you want to replace your image? Of course I do. Yeah, that was the wrong image. Even if you didn't delete it, you will still have to do a re-upload because the image gets saved to Edmentum. So go here. We're going to go to Snip2. I don't know why I called this Snip2. It should have been Snip3. Great. Now I don't have a Snip2. And boom. The focus is where the focus should be. The directrix is where the directrix should be. And we can see the parabola. Perfect. So that's going to end it for this video. Looks like I might only have enough time to get 2 videos out, and I think this is going to end up being a 3 video series. So I apologize for the delay. This one just took a little longer than I was expecting.